Okay, so gonna continue where we left last time, which is part 2 now. So we're able to perform these expressions. So now what I want to do is to focus on the error handling, because we didn't do any error handling here. So if I add something which is weird, it just crashes. So let me just validate my parser, because I saw even here there was a mistake, because we have a modulus but here saying p, so I need to change this one to modulus. Okay, and then okay, let's just do the error handling before we jump to the rest of the stuff. So let me just group my stuff. Have the VM here, take this VM to this folder, even this opcode, they are part of the VM, just to move them here. Okay, let me import this. Let me reduce the sound. Playing my own music anyway. So let me import the token, the VM, need to import the opcode, and then handler. Just gonna call this one handlers. I'm gonna have expression, or let me call it the method handler, expression. I don't know, but for now call it expression handler dot. So gonna create the function which will handle the errors, and also need to separate this from the VM. So VM store dot. So this one will be the one which manages everything. Because I'm just avoiding the fact where we're gonna have issues related to when we try and use this store in the expression. It's handler, not handler. Handler, okay. So start with expression add, or maybe plus expression plus, and then expression minus expression times. Okay, let me do the plus. I need to create the function which will help us to type check. Save or let me call it types. Eval class eval types. These are types when you evaluate, so I'm gonna have var static list, static string list, such as types, and then we're gonna have list, and then a number. The double, it's part of a double int is a number, just to keep everything simple. Make the types lowercase, and we have boolean, and then we have number boolean, and then we're gonna have map, which is dictionary. Let me call it dict, and then we're gonna have now, start with uppercase B, and list. Okay, dict, make this one bool now. Okay, and then we need to do a type check function. Let's see, type checker. Remember, this type checker, it's at runtime, so value a switch case, and then gonna switch the value first, because you might have error. Need to check if the value equals to now, and return eval type dot now, and then the rest we can just say value dot type sorry, dot type checker. What if just checking for this, it's either int or bool. Sorry, or double, and then I'm gonna say it's a number, and then I'm missing one, which is string. Then we're gonna say if we type it's a string, and then return the string. If it's a number, if it's bool, then return the bool. Okay, then I sorted, and then the rest we need to handle them here, or return. Let me check. Just gonna say other at the moment, just or maybe object. Sorry, string. Object, and then I will return eval type dot object, and then the rest, like map and dictionary, can be very tricky because you cannot just check the type. We need to say if value dot dot to string dot lowercase dot start with. If we start with list, and then we know it's a list, return eval type list. Same as map, then say map, which is a date. Okay, so now we have our type checker. Now we need to jump to this var. We need to pop left and right. Left equals to top stack, or I think it's VM stack. I'm gonna check. Let me name it VM stack. VM stack dot pop. So we pop the left, the VM stack dot right equals to VM stack dot pop. Then we pop the left. Then now we need to check var if type checker left equals to eval I think it's eval types should be in the helper. Yeah, it's eval type, this one. So if eval type dot number and right, it's a number, and then that means we can say stack VM stack dot push left plus right. Return true just to exit the loop, and then if left is a number and right it's a string. So that means left it's a number, and then we need to change left to this. If left it's a string and then right it's a number, and then we need to say we need to move this to here. And then if this is a string, if both they are strings, and then it's not necessary, so else we have an error, which is here I need to pass the operator the VM operator up, so that I'll be able to get the token, since this operator contains the knows where the error occurs. This we're gonna remove it. Sorry. So now what you're gonna do is Okay, so I need one error handler in the parser. If you had one, yeah, this one, then I'm gonna put it here at the bottom of this. So we also need the errors which didn't assign. List. VM errors equals to this. Okay, then errors equals to VM okay. In fact, let me just pass the error here. List string. Let's just simplify life because I can see I'm gonna have a big problem. Then have then have the error, then get rid of this, and then get rid of the error here. And then now what I want to do, since I have this handler, so I'm just, when I see plus, the push is not a big deal, so when this one you directly push and you forget about it. When we see plus, then we need to say okay, code, and then comma, the errors, where we're gonna assign the errors, and then yeah, that's it. And then do the same thing for times. Let me check how C++ errors are structured. C++, or let me say C#, IDE online. Maybe if I say one times true, just wanna see how the errors are structured. Maybe you can steal from them. Okay, let me take this. Okay, so just gonna take their errors. Operator is plus. Type checker left, then type checker right. For this one I think I might need to swap it, because I think when you push something in the stack, it's vice versa. So the left might be right, so somehow, but I come back to it. And then if there's an error, we also need to do something, because otherwise we're gonna have an issue here for the program to continue executing. So we need to say we need to set the VM pointer to the size of VM pointer to be equals to VM instruction size dot length plus 1. So we're gonna exit the program as soon as we have an error. And then also if errors dot length is greater than 0, we're gonna break. You just exit the program. Sorry. Then now I'm gonna need these two. Let me just assign it here, assign it here. The times is very basic, and the minus. So if it's a number, let's put this here. Also need these values, otherwise we have an error. This is the same as this is minus. Also need to do the same thing here. 2 times. Let's check if it does what we want. Okay, the stack VM. Let's run it and see if everything is still fine. Okay, you still get 4, which is great. Let's just add the rest of the method. Minus, duplicate this, divide, modulus, divide. Okay, so just gonna duplicate this, modulus, then we're gonna have divide, then this will be divide, and then modulus. Okay. Just that there's nothing to prove with, but error handling is working. So can do something similar to Python, where if you say maybe x or string x multiplied by 2, then we duplicate this, but it's not useful. So what I want to do now, I want to jump to variables, which I think it's what's useful currently. Not variables, like identifiers, so that I will have true or false now and so forth. So let me just go to our Alexa. We need another helper for if it's a, just duplicate this. If it's a letter, letter, and then the letter should be A to Z, A to according to regex, and then letter, and then now Alexa, let me add some comments, because sometimes it can be confusing. Okay, and I think we're sorted now. And okay, now we have a letter. I'm gonna call it identifier. I don't know if I should call it identifiers, but if it's a letter, is a okay. This one, the letter handler is the same as this one, the number handler. So just gonna put it here. I'll change it here. Sorry. If it's a letter or current equals to maybe underscore, if you want to start with underscore, or current equals to maybe $, jQuery style or PHP style. Yeah, currently I think, yeah, this is it currently. In that you need to escape it, because $, used to print stuff inside a string, used to pass values inside a string. So as I said, this code for the number is the same. Just put it here. Say current character, so it can be any of these. It can start with the letter or underscore or $, and then after it can have a number. So that's and then after it can have a number, or $, or anything. And then let me delete this. Don't need the dot. Don't need this. there's no error. And now have a simple switch case of the store, and then by default, which is this one, to return to edit identifier. By default, the last one is an identifier, but and then don't have to pass this. Token. Let me check. Maybe it needs a return. Or maybe because of this. Oh, I see. Okay, it's fine. So now I need to add things like bool, not bool, true, comma, false, comma, now. What else? Okay, currently let me add this. And then what I want to do, so if it's true, if store equals to true, and then I want to say true, and then pass true here. And paste it for the last time. Format true, false, null. False, null. Okay, have true, false, null. So now our parser should know true, false, null. So I'm in our Alexa and our parser should know. So now I need to go to the parser. Here. Let me just create a switch case, guys. Switch case, or maybe I can say if type is equals to this, or this, or this, or this. Okay, let me change it. If it's a number, or dot null, or dot true, or dot false, push in the stack. So now here we should be able to say true, and if I run this, you should get an error. Okay, it's crashing. Okay, true. Okay, let me say 1 plus 2, 1 plus true. Okay, I see. There's an error if stack dot size greater than 0, then we can print top. This is an error, but doesn't seem to be printing, or I'm not printing, I'm assuming. Let me go in the main. Yeah, I'm not printing errors. Let's say print VM errors You see, saying a bow and a number. So as I've said, left can be right, right can be left, which it's just complicate life. Let me go. The quickest way just want to swap this to be right and to be left, like this. But in some cases we'll need to swap the presidency, but we'll see. Let me run it now. Okay, now it's fine. Saying a number in the bool, which is a number in the bool, true. We know in which position, because 1, 2, which is the position, this one. So it's saying this plus can be applied to this. So if I say maybe plus 2 or times 2, like this, it's saying 7, because it doesn't know this, and it's true until I do such things, which now error handling is fine. So now we need to add more operation tasks. Okay, so we're gonna go in the Alexa. We need something which is called look ahead. So what it does is just look ahead. So for example, look ahead, check the second token. So if maybe you have 1 plus 2, current will be 1, and then the look ahead will be plus. So it always look ahead this. So we're gonna use the look ahead for such in this situation. If you have double equals to, less than or greater than equals to, not equals to. So we're gonna use it that the look ahead in that situation. Just gonna call it look ahead. So it look ahead, and then we're gonna say pointer plus 1, and then plus 1. So we're adding 1 to this because we want to look ahead, and then we're gonna add 1 in this. Sorry, then I'm gonna define it here. Then I'm gonna call it look as to current, or maybe look ahead. This is the situation if current equals to this, and look equals to this. and then we can say can return the token, and then we move twice, next, and then now we have double equals to. This one represents the double equals to. So I need to define in the token types. Just group this, group this, group this, group this. Okay. Just equals equal. I'm gonna call it equal, equal, equal. Then I'm gonna call it not equal. Sure you are familiar with this name. Then we're gonna have equal to, and then we're gonna have less than, less than, less equal. Let me call it less and less equal, greater, greater, equal. Okay, and then let me assign them in the lexer. This is equal, okay, if current is equals to this and look ahead equals to this, and then we know we have equal to, and then if current equals to this, and then you know we have less, less. Let me call it less than. Done. Let me just add this done. Okay. Less than, if it's equals to this, and then next, less equals to less, less, and then cool, check. Less equals to, and I'll duplicate this, greater, type that greater than, that greater equal to, sorry. Okay. Not equal to, okay. Then now we have this, which is I still need to update our grammar. I'll go to it. So now we have this, which is relation start. Then I need to end the relation here. Okay, we're done. We're not coming back to this. Greater than or equal, greater than, less than, equal, less than, equal to, equal, not equal to. Okay. Now we need to go to our parser, and I'm gonna duplicate this code. As I've said, this code is the same. And I'm going to the token, copy this, because I'm gonna use this also in the old code. And then now in the parser, also need to go back in the grammar rule. Okay, let me delete this. Our grammar rule was like this, and then now we add another one, which is relation. It's a function which now takes the expression and the expression, which are less than, less or greater, equal, or equals to, or not equals to. So these are the relation which now we're trying to achieve. I'm gonna change this one to relation, and then I'm gonna change this one to expression, and this one to expression, less than, dot less, equal. Then I'm gonna duplicate this, 1 2 1 2, then less than, less, equal, and then greater than, than, equal, and then okay, less than, then equal, and not equal, then less than, change this one to less than, greater than, let me change it to less than, equal, less than, equal, so that we are consistent. I saw there was a floating modulus, this one. Such as minor mistake we do, and they end up breaking the grammar. I'm missing something. No. Break. Got sinuses. Sorry. Greater than, okay, then equal, not equal. Okay, now we've registered all this the relation, so let's just call it in the main, instead of saying expression dot relation. Okay, so now okay, let's define them in this one. So since this one it's kind of dirty, I'm just gonna steal one of the method, then I'm gonna define it on here. I'm gonna call it a relation handler dot. I'm gonna paste it here, import equal for equal we don't do any type checking, so we're just gonna say stack just gonna call this stack and push right equals to left. And then not equal to, also not checking if it's a boolean or just doing this, except for less than, because for less than we know very well it should be a number. So if it's a number and then say for less than equal, still the same approach as adding less than equal. Sorry for the noise. For greater than, still the same approach, greater than, and then greater than, greater than, and greater equal. Also need to change this less than to be less than equal. Okay, let me check. Equal, not equal, less than equal, greater than equal. But I think that's all we need. So now in the VM here, so equal not equal. Already have them, so you see we're using the same code over and over. So less than just dot less than equal, okay. Let me create the last two dots, which is greater than equal, and then change this one to greater than. Okay, Now when we test, it should work. If we're saying 2 is greater than 2, let me try. 2 greater than 2, we should have results, which is false. Okay, 2 greater than or equals to 2, okay, which is true. 2 not equals to 2, which is false. 2 plus 1 plus 3. It will only execute this this part because it doesn't know us this. But when we do this, we should have results, which is false. If you say 5, which is correct. So with the relation in our grammar, we are done. So we have the factor need to update. We have true, false, now. Because if I can do this now and say, which is false, now it's true. Now equals to now equals to true, false. If I say true is greater than now, it should be an error. You see? So we have a boolean true and now, so our type check is working. So yeah. Okay, so I think for this one I'll try and keep it short. Let me see if I can add. Okay, I can add the last part, which is and or. Relation. So now we have and equals to relation. It's a function which will be and relation, and then the last one it's or, and then or, which is a function, will take and or and. So this is our grammar. Now we'll just implement these two. We still need to assign and or in the parser, in the lexer. So let me add them here. And comma or also in the op and comma or, and then now in the lexer I can do it here. So to keep it simple, I just create a map which will take care of everything, because otherwise it will take time. So var let me call it list or map, the string, which is the name, comma, token type. Tokens are, let me call it keywords. just to simplify life. So what I will do now, here, if keywords dot contain store, if it happens any of these dot contains the keyword, and then we say and then we're gonna need the keyword and then we get it from store. The type is complaining that should check for now, and then I need also the store. This now checker. Dash. Okay. Let me say, because this will require me to don't make any difference. Let me see. Okay, I'm gonna come back to this one. It's just complicating life at the moment. Let me just say and stop. Or okay, I can say or and okay. And then now I need to define this. Alexa handler, the parser. Okay, so what we need, I'm just gonna copy the same code and then I'm gonna paste it here. Just gonna call it end condition, which is the end, and then this one will be the relation, and then this one will be end, and then this one will be end, this one will be end, relation, and then this one should be relation. Then copy the same code and then or, and then it's end. Then we say or and then it's end. So now if you in the main, if now we say dot or, we should be able to use and or, but you still need to define it. So and or handler. Okay, I'm gonna store some of the methods here. I'm gonna store this one, put it here. This one. So now and then or expect a boolean. So instead of number, say bool, expression end. also say end, and then end, and then expression or expression or. Okay, and then now I need to define them in the VM. Copy this expression, say end or expression and expression or. Okay, it should do the magic. So now we should be able to say true. True equals to true, which is true. True or false, which should be I don't know if this is true. I think it was supposed to be true, but it's fine. So let me see if I say left. True or false, and then it seems to return false. I don't know. Let me see. Check in JavaScript. Script. Let's play code. I just wanna see if I'm right or wrong. Console. True or false? What is true? That means there's an error somewhere. Okay, let me verify on the Alexa first. True, which is false, which is true. Okay. And then on the parser, okay, the relation, the end. That's very strange. Let me see. Okay, it doesn't seem to be running here. There's nothing. Maybe I did a mistake on the VM. Let me see if it's running here. Also here in this running. Okay. Let me test. As if it's running here. Okay. it's reaching. Oh, I see, I forgot to change this to O. Okay, that should be fine. See, okay, now it's fine. Yeah, I think now you can extend it true or false or true. And false. Let's say false, and you can just extend it to prove that it's reaching here. You can say +1 or +2. Let's see, line 42, which is 142, and 142, which is this one. So it's reaching here. So let me just add parentheses in case you have something like this, so that it will also work. And Alexa, okay, I'm gonna add it. I'm gonna add it inside here. Let me create them. Okay, so just trying to group things as possible as I can. Just gonna call this one L par parenthesis. Then gonna call this one R par. Okay. And then in the factor, let me go to our grammar rule. So we can do it here in the sphere. So if it's or, which is this, if it's this, so we're saying it can be a number, true, false, null, open bracket, or, which is this, and closing bracket. If type equals to I don't know how they write this with there. This is the width. I'm gonna need this error. A lot of stuff. Gonna come back to that one. Okay, so I'm gonna need this arrow. Gonna need this. Next, which is open parenthesis var exp equals to all condition. Check on the grammar. We said it start with the open parenthesis or and the closing. So we have the open parenthesis, and then now this is the or, and then now we need to check if we have a closing. In fact, let me just do it here. If type not equals to token type dot r, if it's not equal to a closing parenthesis, and then but I can get the value from here, and then we return false. Hence you have an error, otherwise you return the exp. So, and then we need to say next if it's successful, and then this is our closing. You see we have our opening, the or, our closing. So, which is the same as the one in the grammar. We have the opening, the or, and the closing. So the reason we have these things are recursive. It's a recursion. So yeah. Let me see if that should work. This should work. Let me try it. Let me say 1 plus 1 plus 2 plus 3. Okay, this is not recognized. Maybe I made a mistake, but I didn't, according to because it's the left parenthesis unless I see a bug, so I need to remove this. See, now it's recognized. So this is working. You can say it's greater than 2. Let's see. Or it's greater than plus 2 times 3. You see, it's working. So if we look at our VM, let me see CLS. You see, these are the instructions, which are these ones. So yeah, that's it. Gonna continue later for part 3.